Okay, I want to show off how to do compiler assisted refactoring. So I'm gonna, where is it? Do I have anything? All right, right here. Okay, so I want to separate the following into a function for my parser called build tree. Okay. So when we're done building the tree, yeah, all right. I just gotta get to the point where we start building the tree. So right here, and then paste. And then now notice all the things that haven't been declared. So I'm gonna try to compile like here. And then every single variable that was not declared. So yeah, so right here. So it's eval. I'm just gonna paste elen eval token op count. What else? Operator index. Parops and nesting level. Right, and I'm gonna take the whole thing, yank it, take it over here. Actually, I should. Maybe I should do something like tree tr. I don't think it's called that. Let's see. I forgot how to use this command. Translate or delete characters. Truncate version. And return. Dude, I just want to replace all the spaces with commas and space. Let me look it up on a web browser. So, place spaces with commas, bash. str-s. Is that what the -s flag does? Squeeze every. Replace each sequence of a repeated character that is listed in that with a single occurrence of that character. The last specified array. So -s. Replace it with a comma. Oh wait, I can already do something here. Gosh, I don't know why I forgot this. So I can do space S. Nope. V space S. And then replace all that with a comma. And space R. Yes. I guess it works. I haven't quite worked out the kinks of this macro. And then get rid of highlighting. Alright, so I know that this is an integer and this is an array of tokens. This is another integer. This is an integer, I think, or is it size t? Preacher index. It's an integer array. Let's see. Ops. It's an array of parops t. And then this is an integer. Now, and I notice all of these errors go away. I can just do build a tree. I think, alright, I'll put the function signature at the top. Later I will be changing it. I'll be putting it in ep.h. Right, so what are the rest of these errors? So the rest of these errors have to do with what's it called? Okay, I forget. Oh yeah, with this part. So AST. All right, and now we are down to one error. Now so far we haven't actually used the compiler, so yeah. I thought I would have taken care of this now. I know this is just aesthetic, but it's still ugly. Alright. Where does this whole expected expression come from? Alright, now I am expecting some sort of compiler error. So, or I mean seg faults. So for example, if I do something like main 3+3 segmentation fault, where was it? Nope, I'm not looking for that. Debug memory. Oh wait, I have it defined. Crap. up here. So if I define it, what the frick do I need to do something like this? Included is type def of okay, I guess I never used this. Whoops. Alright. So the last malloc we did was at main 146. Which is here. And I think it might be useful to go to the end here to find out what's going on. So no mallocs are showing up here. That's a little weird. I should just malloc. What am I doing? Chat. What is going on? So let's do some printf debugging before we pull out the actual debugger. Alright, so it ran here. It said 139. Maybe what is this? What was this malloc? That's just the one for parentheses operator. Right. So you have nesting level 0. Let's see how many times this gets printed. Start gets printed once before something like this happens. I think it might have to do with accessing parops. Start. So start happens once. Start still happens once. And maybe it's here. Alright, so segmentation fall comes from this. So operator index. So that's a pointer. So it either has to do, which I doubt because J is 0 at this point. So it has to do with accessing this first part. So let's go up here. Actually, why? We start at the end here, nesting level, and this one is 0. So is this one. Wait, start is run twice? What the heck? So, wait, what happens if we do wrap this in parentheses? Still, okay. Let's think about it real quick. If I is 0, it definitely has to do with accessing this right here. I'm pretty sure because let's see what happens if we do something like 4. Dude, why can't the snippets not give me like BS? Like, I want to program C, right? I do not, what I don't want to do is actually, let's do this. Alright, the starts do something here. Oh, okay, so it's after that. I'm silly. Now, I mean, I like the size and the amount of operators. This one should be 1. This one should be 3. You set these here. Right, we set these to uninitialize. No, I call it debug start. Comes after, okay. Actually, I should do something like this to make sure, actually, doing something for real, for real. What happened? Root index. Yeah, no, that would return errors if I wasn't paying attention. So it works at 0.60. And let's see how many times it prints. So it printed one time and then kept going. Huh? What do you mean? But we're not at line 164. Wait, what did I do? Okay. I'm silly. Okay, it works at 192. I also forgot to return this. Oh, it's because I forgot to return. What the heck? Okay. Yeah, so that was stupid of me. The whole reason this didn't work was because I forgot to return. Yeah, so that should give you an idea of how compiler assisted refactoring works, or at least error assisted refactoring. So now I'm going to be moving this into ep.c and also making some guards, function headers. So yeah, that's about it. Let me